Okay, thanks Priscilla for agreeing for me to record while we talk about this question. So you asked me how to go about solving for the mass in grams of a substance that occupies this many milliliters and has that density. And there's really two ways to do this. You could use the equation, and I'm going to say don't do that. That's going to make your life harder in the long run. So one way that a lot of people do it is they write out the density equation, density equals mass over volume, and then they just take this density and plug it in there, and take this volume and plug it in there, and then plug in X for the mass and solve for that. Or just leave the M letter there and solve for the mass algebraically. And that would work great in this particular case. It'd be easy. But there's a better way to do it, a faster way to do it here, which becomes much faster in the long run. We want to treat this like a conversion problem. So I'm going to clear that out, and I'm going to show you how I'd like you to think about this now, which I think will really help you out in the long run. So first off, identify what's being asked for in the problem. And it's pretty straightforward. What's the question asking for, Priscilla?
You're asking for the mass in grams.
Mass in grams, right. So I always say write that on the right-hand side of the screen, the unit that you're trying to solve for. So we're going to do this like a conversion problem, which is the most common way we do any kind of math problems in chemistry. And then since that's a single unit grams, we want to start the problem with a single unit and then find conversion units to get us there. So what's the other single unit that you see present?
The 350 milliliters.
Milliliters, perfect. That's exactly right. So that's 350.0 milliliters, and that's what's going to set up the problem. And now we're going to look for conversions that can convert from milliliters ultimately to grams, and maybe we can do it in one step or more. And those would be like ratio units or equalities. Something is equal to something else, or something divided by something else in the units. So, I mean, it's probably pretty obvious now, but you can spot the ratio unit that includes milliliters.
The 2.21 grams of milliliters.
Yep, so that's it. That's the ratio, 2.21 grams over 1 milliliter right here. So would you mind annotating my screen to show how to fill that in to this problem?
1 second, let me get onto my annotate. So then I want 2.21 grams over the milliliters.
Yeah, exactly. You definitely need to put the milliliters on the bottom because you need the milliliters to cancel. And then that would be understood to be 1 milliliter. You can fill in the number or not, doesn't really matter. And then that'll put grams on top, which is perfect because that's the unit that you wanted to end up with. So you're done here. All you got to do is plug that into your calculator now. 350.0 times 2.21. And I'll do it at the same time to make sure we get the same number. $773.5, which is exactly right. You've got the unit of grams, perfect, and we'll double check sig figs. And the easiest way to do this, in my opinion, 9 times out of 10, you're just going to want to go back to the original problem up here and count sig figs there. So this is a 3 sig fig number, that's a 4 sig fig number. So how many sig figs should you be rounding your final answer to?
So we want 3.
3. So 1, 2, 3. So go ahead and write down what your final answer is going to be. Perfect. That is exactly right. So that's really the best way to go about attacking problems where you could use density as a conversion factor to get to your answer. The reason isn't because of this problem. This problem is easier this way, but it becomes much, much easier if they were asking you for something like kilograms in the end, where you'd have to use density and then use a separate conversion. You can just stack a couple conversions together and you can get done very quickly. Where if you had done the algebra, you'd have to do the algebra step, then separately do a conversion problem, which is a much, much longer approach. So that's why we want to recommend learning to use density as a conversion factor like this. All right, that's it. I'll stop recording now and we can get back to regular office hours.